Hey guys, this is Project 2, a magnetic part stand for ME3210 Design and Manufacturing at Georgia Tech. So we'll go ahead and hop right into it. The reason that this project is personal to me is that I do a lot of karting. This is kind of my main hobby, and what we use to lift the cart up to help work on it in between sessions is we use an electronic cart lift. So it's a winch mechanism on top of a stand. You can see the video here on the right will help demonstrate how it works. But essentially what it does is it lifts the cart up just using electric power. So nice, easy, simple mechanism to essentially move it up. The problem comes when trying to work on the cart. You're dealing with a lot of different tools for a lot of different components that are very specialized and a lot of different nuts and bolts that you really should try and not lose. So you're dealing with that, and then you have nowhere to put them typically. So what I've designed is a magnetic stand for that. When you're dealing with all of those tools, it is important to keep them in one place and make sure that you're able to essentially attach it anywhere, move it around, make sure that that plate is able to hold anything you need to in order to make your job easier and essentially shorten up times, prevent you from losing things, etc. This is a detailed description of the part. It's an attachable metal plate to provide a platform for tools, nuts, bolts, washers, or any other critical part that needs to be stored properly. It can hold a lot of weight. It is simply a tensionated hook that you can attach and apply anywhere. It's deconstructible for easy transportation. So the two clamps that are on the bottom of the metal plate, when we get into its construction, we'll discuss a little bit more, but it's able to move anywhere and everywhere. You see the picture on the bottom, the little infographic that I made of different places it can attach to. This is made to be able to transport all around. It's not great of use if you're not able to move it just about anywhere you would possibly need to work on it with. So it can attach anywhere on top of the body itself, or to the chassis or any other metal part. It is designed for easy manufacture with large tolerances and specifications, easy to make injection molding for the plastics, easy to mold and insert threads, and easy to form and magnetize. It's designed for ease of use, just for easy accessibility to the product, mobile function, and making sure that it's easily transportable and attachable to any place on the cart. The platform is removable, which allows for greater access and easier transportation. When you're stuffing all of this in a toolbox, you're trying to minimize that wasted space. So being able to have the customer take it and then be able to deconstruct it and then take it out next time, while being able to pack it really compactly into any sort of toolbox or chest is really, really important. And it attaches with a clamp style mechanism that is easily transferable around the main lift's body. It is a tension clamp, also to make sure that your manufacturing and your part design is as easy as possible and as easily replicatable as possible. A lot of parts in the racing business are extremely expensive because they are so specialized. So really being able to cut down on cost while also having a useful product that is able to be used here. Plastic holding mechanism right here is the clamp mechanism for being able to attach your main plate to the actual cart itself. So you see there is a machined magnet and an industrial adhesive applied to the bottom of that rests into your plastic holding mechanism. You can see the rest plate there where the magnetic metal plate easily slots in, your adhesive and magnet location, and then also where you clamp it down, essentially just nice and easy, hook it onto any part that you need to be working on really closely, and be able to slot the plate in. This is the actual magnetic plate itself. So you see there's the main compartment with the plate with nice, easy filleted edges. As always in manufacturing, there's no such thing as a straight edge. So it is essentially as close as you can get, but also making sure that it is within safe, reasonable distance. When you're working in a tight area, the last thing you need is a lot of sharp corners everywhere. So being able to tamper those down, make sure that you're not doing too much. But with the main compartment and the secondary compartments, you're also able to separate out nuts and bolts. This is what it's mainly for, is making sure that you're not losing different things. And you're able to keep them nice and close by. So no matter how big or small, making sure that you're able to locate those all around. The magnetic plate itself is 12 inches by 10 inches, so it provides a decent amount of space for just about any tool that you need to attach to it, essentially creating a really nice space to work in. Nothing that you're going to deal with is that you're going to be worried about losing small parts with is going to be bigger than that, and it's also small enough to where it can fit in the tight areas as shown in the infographic on slide number 3. Here's the full CAD of the part itself, so you can see those plastic tension clamps are attached. The actual main magnetized steel sheet is laid across them, and then because it is magnetized, those embedded magnets that have been adhesive to the actual tension clamps themselves, those are able to simply connect to the main magnetized steel sheet, and that allows it to stick. So if something gets bumped into or you become at risk of falling, then it is very easy to readjust or reposition, and it's also not going to fly out and you're going to lose your parts, which is what's prevented. There are large tolerances, so it's very easy to keep track of where things are, insert the plate in and out as needed, and move it around as needed. The plastic clamps are made of injection molded plastic. They're extremely easy to manufacture. It is going to be extremely cheap, and it is going to be strong enough in order to make both the shape and also not degrade over time. Industrial adhesive is used to attach the magnets to the plastic plate, while the industrial magnets themselves are made of the exact same manufacturing process that the main steel magnetized plate is. And that's going to just simply be CNC machined steel using face milling, climb milling, and cutting tool operations because they are both easy to get through CAM, easy to use with only a small amount of tools, and then the magnetization process can be done in a simple industrial magnetization machine, which can be found in most industrial settings that you deal with magnetization and manufacturing of magnetic products. Materials used in production, the big things are the polypropylene plastic, which is both strong enough and cheap enough to work, and the 430 grade stainless steel. That's going to be your steel of choice for making sure that not only it doesn't rust, but it's also going to make sure that you are able to cut through it with the CNC machine and make sure that it is magnetized. So it is really the steel of choice for this, and then also your disc magnets and your industrial adhesive. Advantages: simple attachment, easy for the customer to use, helps the organization of tools, prevents loss of tools or parts, easy to clean due to easy surfaces, easily transferable to different workspaces. It's designed for ease of use and assembly. Disadvantages: it's going to add complexity to the actual lift and everything that you do to set up. There's unintended magnetization where it can grab onto certain parts, but that is outweighed by the benefit. More expensive manufacturing process than just a simple sheet, and the magnetism can degrade over time, but when you're dealing with the industry that I was mainly focused in, it's not going to make that big a difference over time. And then here are the resources and a disclaimer that this is for educational purposes only and is not a real product.